My screen is visible, right? Paint.
Yes.
Okay. So today our topic is Kubernetes uh, request and limits. Anyone heard about request and limits? Anyone heard about request and limits?
No.
Okay. So I will explain. Okay. So consider that we have a Kubernetes cluster and we have a node. Okay, I'm just taking an example. Okay, so I'm just taking one node and we have two pod within our that's node one. Okay, so inside the pod one, there's application running. So the container, so the container one and container two. Application container. Okay. Just to see application container. Okay, and this is a normal scenario. So coming to Kubernetes request and limits. Okay, so first we just to go with the first. So request actually represent the minimum amount of compute resources a container require. For example, for example, this is a application container, right? In coming to the pod one, this is a container, and with inside the container, the application is running. Okay, so the application first we need to know the application complexity. Okay, so for example, that application need more CPU in case, okay, or more memory, more CPU or memory. So in that case, we can allocate the resources using request and limits. Request simply we can say request is equal to minimum and limit is equal to maximum. Minimum what the resources that we allocate or we provided within the configuration. The maximum means the maximum resources utilizing under a single application or single container. If that container or if that application require more than the limit, then what happens? The container goes, not scheduler or it's stopping, because our maximum is we set the maximum actually under the limits. So the coming to the request, it's represent the minimum amount of compute resources a container request. So Kubernetes uses a value, okay, like a request value for scheduling pods on node. You got it? So if a node does not have enough capacity to fulfill the requested resources for a container, what will happen? The pod won't be scheduled on the node. So we need to, for example, mm, the node, okay, first we can take the node. The node have 10 core CPU power, CPU, memory, 8 GB. So we need to assign within this limit, okay? Because our node have only 10 GB and 8 GB RAM. So when we configuring request and limits within like pod or container, we need to set below the requirement. Otherwise, the pod is not scheduled. Then coming to limits. Coming to limits, it's represent the maximum amount. Here the request is only minimum amount, okay? Minimum amount. Here maximum amount of compute resources a container can use. So we can set the value under the limits in the application YAML file. So both are we use in the YAML file, okay? Like we have a deployment YAML or application YAML. So in that YAML, we need to add these requests and limits, and we need to mention the minimum value for that application and the maximum value for the application. So what happen when we're running that application? It, that applications ensure that the minimum resources, and we can ensure that the application does not take more resources, only within the maximum. So coming to limits, if a container tries to exceed its defined limit, okay. For example, we have an application and that application tries to exceed the limits, okay, the set limits. In that case, what will happen? It's that container goes to throttle state, okay. That means it's going to down. It's not running that application because that application requests more than the maximum. So coming to problem statement, okay. Coming to problem statement, for example, when we deploying an application Kubernetes, resource over allocation or under allocation can cause us issues. For example, coming to the node, we have this much resources. So if we uh, allow like uh, more resources to any pod, or because that application does not need that much resources, but we allocate more, then it will cause the entire cluster. So we, for example, the application grows in case. So that time we will, there is a lot of work there actually for managing those containers and application. So coming to the resource over allocation or under allocation can cause the issues. for coming to the over allocation can lead to resources contention or affecting application performance. Those are the issues coming to the over allocation. Coming to the under allocation, the result may be container being killed or throttled, causing degradation in performance. For example, without request and limits, a purely optimized application could use CPU or memory on a node. So that will be leading to other containers being starved of resources. So anyone have any doubt regarding request and limits? So for example, if you take a YAML file, okay, just take example. For example, we have a YAML file, YAML application.yaml, okay, application.yaml. So this YAML we use for deploying our application. So within the YAML file, there is like we mentioned the API version first, API version, then the Kubernetes resources like the kind that will be deployment or pod or anything, deployment or pod. Then we need to provide the metadata for the YAML like the name, label, everything. Then we need to specify that the image name for our application. Then after, under that image specification, we need to add the resource. Under the resource, we need to add request. Under the coming to the request and limits, we mostly concentrate on memory and CPU. Okay, memory and CPU. Memory and CPU. So those are the two aspects that we concentrate on request and limits. So coming to the request, here we can mention the memory. So we need to provide how much memory that application wants. Okay, that's our request. Got it. That's a needed resources for running that application. So we can mention that like 256 MI. Then the CPU. Memory, after memory, then we need to specify the CPU. CPU. So actually what we have here to do, like we assigning these memory and CPU for running that application. So this is the minimum guaranteed resources that we allocated to the pod or to the container. So what will happen? The node will share the resources from its reserved resources. Okay. So this is a request. Okay. Request means the minimum. Then coming to the limit. Okay. Under the request, we need to add the limits. Same thing, memory and CPU. CPU. So the coming to the limits, what we need to provide here. Anyone can?
Value?
Yes. It's less than the request or more than the request. Anyone?
Question, please.
We set the request, okay? like that application needs this much resources. So coming to the limits, we need to specify the value, right? So the value is more than the request or less than the request.
Less than, I guess. Is it less than?
No, it will be more than the request because always, we may not know that the future how the application is going to.
Right. You're right, Mahesh.
Because
limits is actually
use
maximum.
Correct.
Request is minimum. Got it.
Yeah.
We need to mention more value like 500. That would be fine. Okay. 500 MI. Then the CPU goes to 500. So what will happen? That specific application or the container got 256 memory and 250 M CPU. That this is a milli-core, okay? We define as a milli-core. So this much resources assigned for that application. And if the application need more, what will happen? It can take up to 512 memory and up to 500 millicore. Got it.
Sir, so, what if the application needs more than 512?
Then it goes to throttle. That's why we are assigning that resources. For example, if some cases, some application have memory leak, okay, the actual application does not need that much memory, but if that application have any memory leak, what will happen? That specific container will take more CPU if we does not, didn't provide the request time limit in that case. Okay, so what will happen? It will take all the memories from that node. So what will happen? We can't deploy any other application within the node because all the resources taken by the single container due to the memory leak. So several other issues are there. So that's why we restricted with the request and limit. So we can ensure that that specific application or container taken only the resources between request and limit. If they need more, then it's go to throttle state, like stopping state or like that.
How can we fix them?
Memory usage, right? Or CPU usage.
In both cases.
First we need to know that application needs that much resources. If need, then we need to add more resources. Otherwise,
more resources.
Otherwise we need to talk with the developer team that these applications consume more resources. So they will troubleshoot the issues, some application issues, code issues or anything.
So, sir, every time we are supposed, like, we will be creating the resources every time, or it depends upon organization to organization?
For new application, we need to write up the YAML file actually, as per the requirement. This is the best practice actually, using request and limits.
So actually, why I'm asking this question, I was talking to one of my friend, and he said like his team basically creates the format, like the one which you showed, like where we were creating all the resources, so that format, and then they give that format to their contractors, the consultant people. So those people then, like the DevOps, those contractors are the DevOps, and they just put the information and do the rest of the job.
Right.
So that's why I'm asking. So do we need like it depends upon organization to organization that we need to create that template file, the YAML file, right from the scratch.
No, not. No need to write up from the scratch because there is a format there for an application.
Okay. And that format has been written
Customize.
by
We can
developers.
customize. We can customize.
We can
as per the
customize,
request.
right?
Yeah.
Okay, sir. Okay, yeah, got it.
So anyone have any doubt regarding request and limits? No doubt, right?
I'm sorry, I don't think I got very clear about like you specify the requests and limits in the YAML file to say what your limits are.
Right.
And how do you, what is this, which YAML file is this? App.yaml.
Yeah, I will show you. Okay. Format, YAML format. You can see my screen, right? Like Visual Studio Code.
Yes.
See, this is a simple application, YAML. So here we can see the application API version, then the kind. This is the resources, okay, like vendor resources. So this will create a pod, then the metadata, example pod. Any name we can give here, okay, the application, for example, my app, like that. Then the container, we need to specify the container name and the image name. So this is the image name, Nginx. So it will take the Nginx image from the Docker Hub and run the application container. Then under here, you can see the resources under the image. Then we can mention the requests and limits. So coming to the request, we need to mention the memory and CPU. How much memory and CPU this specific application need? That is the minimum, right? So we need to mention that memory and CPU value here. Then the limit. I mean, how much that specific application maximum utilize the resources. That's under the limits. The memory, it goes to 512 MI and the CPU 500 M millicore. This is a millicore, okay. Now you got the idea, right? For example, if you run this application, this specific application
Is millicore like how many? Is the core divided into milliseconds? Like why is it millicore?
one core. 500 means half core.
Half core. Okay.
Milli is one core, right?
Okay.
Yeah.
But you can give fractions of core, so they divide the clock time into fractions.
Yeah, because coming to the node, there is a lot of containers are there, right? So we need to divide the cores.
Okay.
So you got the scenario, right?
Yeah.
So what will happen if that specific application need more than 512 memory? In that case, that application goes throttle state, or that application, it's going to throttle.
Okay.
And how can we, sir, check like how many extra resources we can create here? The maximum number of resources we can create for this specific application? where we find that information?
Maximum means this, right?
Mm,
Maximum
no.
limits, you mean the limits, right?
No,
Or
if we need more memory, then we need to create more resources, right?
no, we can change it here. This is just an example, okay? I mean,
Yeah.
for example, the specific application need 512 MI. So what we need to do? We need to ensure that using the request,
Mm-hmm.
okay? Or else this specific application needs only 256 memory. But in some case, some loads are there, so we need to ensure that it's need more memory in that time. So we can change the limits. I mean, higher the limits, like from 512 to 1024, like that. That's all as per the requirement, actually.
Okay, sir.
So we can ensure that only that specific application taken the resources within the limits.
So why we will approach to the developers? Because we can fix it
No,
here
no,
at
no
our
need,
end.
no need to connect with the developers regarding these things. For example, if any issues with the application, okay. For example, we have a application, okay. Um, I will explain. You can see my screen, right?
Yes, sir.
So we have a pod, a node, and inside the node we have three containers, three pod, okay. That three pod contains same application. The replicas is three. So what will happen? It will create three pod with the three containers, right? Yeah. This is a node. My paint is visible, right? Node
Yes,
one.
sir.
Yes.
This is pod one, pod two, and pod three. These three pods contain same application because in the YAML we set the replicas as three. So it will create three instances of the same application. So it will create three pod and three container. So these are the containers, okay. Container one with the application. In container three, application. So we didn't for example, we deploy the application without request and limits, okay. So what will happen? These two applications running fine, okay. This application only taken like one core to two core. Just example, okay. This also same 1 to 2 core, only taken that much. Coming to the memory, 500 milli to 1000 milli, okay. That much this application only taken 5 milli to, that means 500 memory, okay. And 1000. So this application, the third applications taken only this much resources. But coming to the first application, this is an example, okay. I mean, how that specific application taken more resources. So the application one, it will take more than like 1 to 5, or coming to the memory, 500 milli to 1000 or 2000 memory it will take. So in this case, all applications are same application, but only one container or one application taken more resources due to some application issues or some code issue or anything. We don't know what happened. But in this case, what we need to do, we need to talk with the developer team to recheck the code and push take in, okay. So this is one of the example. That's some specific containers or specific application taken more CPU or more memory. So
Okay.
this case we use request and limits. So we can ensure like it's a uniform format, like all the application only taken the, I mean the limited resources that we specified under the request and limits.
Okay.
Got it.
Yes, sir.
Anyone have any doubt? All are good, right?
Yes,
Yeah.
at least me.
Sorry.
I'm good.
Okay. So I think I'm planning a lab actually for the same, so you will get more idea how these works. So what will happen? I mean, we can create a Kubernetes cluster, then we need to deploy some sample application, and then we can include the request and limits. With the request and limits, we can check, and we just push some load to the app container. So how the containers handle that load? Okay, so you all can see the real scenario. Got it.
Okay.
So, sir, I have one question. I'm not sure if I'm phrasing it right or not. So, Kubernetes, like the lab which we did before, that was a self-hosted, right?
Yes.
And self-hosted means like it will do all the things, right? It's not like EKS. EKS is different.
EKS is managed by AWS.
AWS, yeah.
That means AWS offer a Kubernetes service that is fully managed by AWS provider, and they named as Elastic Kubernetes Service.
Hmm. Hmm.
So
So,
it's there. This is same managed by Azure. Azure Kubernetes Service, same thing. Finally, we got that Kubernetes. If you go with EKS and AKS, then GKE,
that's Google.
yeah, managed by Google.
Hmm.
GCP actually, Google Cloud Provider.
GCP.
This is Google Kubernetes Engine. So these are the common managed Kubernetes services. So if we did not need that managed one, we can go with the self-hosted one. That means we need to manage entire master part and worker part. So in these cases, we can simply deploy the entire Kubernetes service within a command, or we can go with the dashboard and just provide the details like the name, configuration. Then yeah, simple way we can create these managed services.
So mostly companies uses their self-hosted.
Managed.
Managed.
Yes,
Okay.
because it's
So,
easy
sir,
to manage.
it's easy to manage.
Yeah.
So, but we are learning self-hosted, right?
No, we go with the EKS, right? I hope you attend the classes, Kubernetes classes.
I did. I think I missed one or two. So that's why I was asking for the videos. So
You
yeah,
you missed the EKS class, right?
I think I missed one Kubernetes class, and I don't know what happened in that class.
I
So
think
that's why.
145. So tomorrow I will show you how to create a Kubernetes manage a Kubernetes cluster. Okay, AWS, and we can do the application deployment using request and limits.
Okay, sir. Okay.
Yeah.
Yeah. Thank you. Thank you, sir.
Anyone have any doubt? All are good, right?
Yes.
So then we can continue tomorrow, right? Because I don't have the Kubernetes cluster today. It will take some time if you go with the lab.
Okay, sounds good.
Then
See you
we can
tomorrow.
connect tomorrow and we can do the same lab like request and limits using EKS cluster.
Okay.
Okay.
Sir, when can we have the rest of the videos?
I will
Because
today I will try to
so what's the problem? Like it's been lingering from a long time, right?
the
Is it
problem.
like you're not getting it
Yeah,
from the other people?
yeah, I will post it today. Okay. Otherwise, I will share the content of the batch 2 as well. No problem.
Yeah, because EKS is like I'm a bit confused between EKS and Kubernetes, like the self-hosted Kubernetes. I was trying to, read it by myself, like, but then I got
Now you
confused.
got the idea, right? What is managed?
Yeah, it is something similar, but still, like, it's not 100% okay with me. I just want to see step by step what's the difference in both the cases.
Mm, okay, then I will briefly explain. Okay. So different way we can use, leveraging Kubernetes services. Okay. For
Hmm.
example, as a testing purposes for
Hmm.
testing application. So in that case, we mostly using self-hosted. How we will use, set up that self-hosted using a tool called KubeADM. Using the KubeADM tool, we are going to create a master part. Installation of master part. Okay, installation. Where we installing the master part using Ubuntu machines or the Linux servers. Ubuntu. So what we need to do first? First, we need to set up a Ubuntu server, then install the master part and worker part using KubeADM tool. Worker part will be the node, the EC2 machine. Consider here we taken one EC2, one for the installation of master and EC2. We take another EC2 machine for the worker part. For example, if we have one more EC2 machine, EC2 3, that will be the second worker part. So we will get two node. This is a EC2 2 is the one node and EC2 3 is the second node in our Kubernetes. Got it. So
Yes,
most
sir.
probably we use for test cases, okay, self-hosted Kubernetes. We will get the same kubectl, Kubernetes environment using kubeadm. Then one more cases for learning purpose. For learning, we use Minikube. Minikube is a very lightweight version of Kubernetes. So we need to use only one machine. Take a Ubuntu server or any Linux server, then we can install the packages of the Minikube and we can start the Minikube. Only we need a single server and we can run the Kubernetes. We will get the Kubernetes there and we can run the application or testing application like that. This is for learning purpose, okay? If
The one
we
which we used in our Jenkins pipeline, right?
no.
That was different.
Minikube, right?
Yeah, that was a mini cube.
No.
We installed the mini cube, I guess.
Install the Minikube
I'm
where?
I think I use a Minikube command. I don't remember exactly, but Minikube is something like familiar to me.
No, no, Minikube is a very light version of light Kubernetes version. Only
Okay, sir.
for, I mean, we can learn Kubernetes commands and we can deploy small applications within the Minikube. That's all.
Okay, sir.
Yeah. Give me a sec, okay? Yeah. So these are the different scenarios where we using Kubernetes actually. For production, we use managed one like K8s or EKs as per the which cloud provider that we use. Understand? All of you. Hello? Hi.
Yes.
Ah.
Yeah.
Yes, Tawfiq.
Yes, sir.
Are you
Then
showing the print screen or are you showing some other screen?
paint.
Okay.
This one. Yeah. Then we can continue tomorrow, right? To the part, I mean lab part.
Okay.
Yeah.
Yes,
Then
sir.
we can bind up, right?
Sure.
Yes.
Yeah.
Thank you, sir.
Bye all.
Thank
Yeah.
you, sir.
Bye-bye.
Have a good day. Good day too. Bye.
Yeah.
Thank you.